Good afternoon or evening. This is Mr. Humbard here. For this assignment, going through the Chapter 3, Section 2.2, Part C assignment. So, if it's starting from rest, that is our velocity initial. Here is the displacement, change in x, 11 meters, and here's our time, 2.2 s. So what we're going to do first is plug in our values using this equation. The change in x equals velocity initial times the time plus 1/2 times the acceleration times the time squared. And when we do that, we have 11 equals 0 times 2.2 plus 1/2. Then a, don't have that, 2.2 have that squared. So this is going to go away. I'll get 11 equals 1/2 a 2.2 squared. What we're going to do is find what a is. So a equals 2 times 11, so 22, divided by 2.2 squared. So I multiply both sides by 2 to cancel the 1/2, and I divide it by 2.2 squared as I want to isolate a by itself. I'm going to get 4.554. And these, it's to 1 decimal, so we look at all these, look at only this one. This is a 4, so that's lower, and we go cancel that because we want 1 decimal. So 4.5 is our answer, like we have. For the second problem, what I'm going to do is rewrite everything, but this time I'm going to do it a little differently. I'm going to go up to this equation thing, and I'm just going to use what's given. This is the equation I can use. I'll plug that in down here. And how I use it is I get all the variables, I plug in what I have, it should give me the answer as well. So a equals 2 times the displacement minus velocity initial times the time over a. So when I do that, over t squared I should say. When I do that, I plug in my values, it's going to be 2 times 18.4 minus velocity initial, it's at rest, so it's 0, over the value for time squared. 2.09 squared. And once I do that, I should get 8.4247. So round that to 2 decimals. And there's a 4 here, so we kick off the rest of them. Now round that up to 2. Let's make that larger. So here is our answer, 8.42. For number 3, I'm going to find this displacement. So 5.21 plus multiplied by the time, 7.03. Redo that. I have to remember I'm using this equation up here. So displacement equals velocity initial, 5.21, times the time, 7.03, plus 1/2 the acceleration, negative 1.12, times 7.03 squared. And once I do that, I should be getting 8.95 0596. I just want one decimal so I can get rid of all these. And this is a 5. So I'm going to look at this 5 and I notice it's 5. And I'm going to round that up to that 9. So I get a 0.1 out of it, and that rounds that up to 9.0. Because 0.1 plus 8.9 is 9.0. For number 4, I'm going to go straight to this equation because it is a really annoying problem to set up if you do it all in steps. So this is that equation. I could quickly find it if I didn't remember it, if I didn't have that sheet, by just doing a little algebra. So solving this, by subtracting both sides by that, v initial times the time, then multiplying by 2, and dividing by time squared, I isolate the variable a on one side. So once I do that, I plug everything in. 2 times the change in x is going to be 0.0221 minus velocity initial is 44.4, or 2, I mean, times the time, 0.08, there's another 0.855 over that same 0 squared. So when I do this, get it all typed out, I should get 2 times 0.00022 1 minus 44.2 times 0.00855, and then I want to divide all of that by 0.00855 squared. I should be getting the same approximate value, negative 9734.5. This is a 5 though, and it says no decimals, so round that up to this next number, which is going to be negative 9,735. Alright, so for number 5, all I'm going to do is that same equation I did above. A equals 2 times that displacement minus velocity initial times the time over time squared, all over time squared. So I plug in these values. equals 2 times the change in x minus velocity initial time over time squared. That it's going to equal 2 times our displacement, which is 262 here, minus our initial velocity, initial speed, 7.9, times the time it takes, which is 82 seconds, then divided by 82 seconds squared. So once I solve this, 2 times 262 minus 7.9 times 82 divided by 82 squared, I should get negative 0.1147 That's in meters over seconds squared. Alright, so that should be the answer to that. And that's it.